Hey guys, we're going to go over your Saxon 105, side A. So on the first one it says measure the date line using inches. And an inch is about the length of a child's thumb. So this is our inch side. So I'm going to line that up. So we have 2 whole inches. And then we have 3/4 of another inch. Remember when we had our lesson about quarter inches? So there's 2 1/4, 2 1/2, 2 3/4. We haven't quite touched the 3 yet, but we're past the halfway mark between the 2 and the 3. So we have 2 whole inches and 3/4 of another inch. On number 1, they tell us Jaleisha bought 2 bookmarks. And if we look over to the side, a bookmark is 10 cents. And since she bought 2, we're going to need 10 cents for one of the bookmarks and 10 cents for another one. And a folder at the school store. A folder is 45 cents. And the question is, how much did she spend? So we're going to add the 10 cents a piece for each of the bookmarks and the 45 cents for the folder. And I want us to practice writing this with our dollar sign and decimal instead of a cent sign. So Jaleisha spent 65 cents on the items that she bought at the school store. And then they ask us, what will be her change from $1? So whenever we find change, we're finding a difference. So we've got our dollar. She paid with a dollar bill, but she only owes the school store 65 cents. So the difference between what she paid with and what she actually owed the store has to give her back in change. So we get to practice our regrouping skills. We can't do 0 minus 5. If the bottom is bigger than top, to my neighbor I will hop. But this neighbor does not have anything that I can borrow. So I come to my next neighbor. I borrow from the left and carry to the right. But I'm not back at home base yet. I like to make a little 2-story house in the ones place. I'm not back to home base yet, so I have to borrow again. So this 10 is going to become a 9. Borrow from the left, carry to the right. Now I can go on across with subtraction. So the school store clerk needs to give her back 35 cents. On number 2, they want us to write this number in expanded form. And we're going to fill it into the place value house. So here's our place value house. And we read from left to right. But when we were doing our place value, we always start at the far right with the ones place. So we have the ones place, the tens place, the hundreds place, and then we've got our comma, and we start the thousands place here. So this number is 6 sets of 1,000, 2 sets of 100, and 50, which means 5 sets of 10 and no singles. So to write that in expanded form, if the 6, if its value is 1,000, we would write it like this: 6,000 plus, if the 2 is in the hundreds place, we stretch that out to 200. If the 5 is in the tens place, that means 50. And then we don't have any single units. Now they've given the number to us in words and we have to put it in digits. When we build our place value house, again, we start at the far right. So we know we have our ones, tens, hundreds, and then our thousands family starts. And again, in the thousands family, we have the 1,000s, or we just call them thousands. We have the 10,000s, and then we have the 100,000s. So I think of this as like a family, and these are the first names, and their last name is thousand. 1,000, 10,000, 100,000. So that number is 35,000. So 30 means 3 sets of 10, 5 singles. There's my thousands, comma. 210 and 63 cents. So when I write this in words, it would look like this. The word cent means 100. A centipede has 100 legs, and there are 100 years in a century, and there are 100 pennies in a dollar. So anytime you see CENT, you're talking about 100. On number 5, our bar graph is numbered by 2's here, skip counting by 2's. So we have to use what we know about the number line and what would be in between to answer our questions. So how many children have blue eyes? Well, the bar for blue is right in the middle of the 6 to 8. What would be right in the middle on a number line of 6 and 8? 7 children. How many children are in room 20? So what we need to do is add up all of the amounts for our bar graph. So we already decided the blue was 7. Let's go ahead and label our graph. The green was 4. The brown is right in the middle of the 8 to 10. So that would be 9. And then hazel eyes is right between 0 and 2, which would be 1. So we can add all those up. 6 and 4 is 11, plus 9 is 20, plus 1 more. That must be 21 children. How many children do not have brown eyes? This is actually a reading test. So to figure that out, if there are 21 kids in the whole class, they want to know which ones do not have brown eyes. So we're going to take the brown-eyed kids out. So we will take out the 9 that have brown eyes. I can't do 1 minus 9. If the bottom is bigger than top, to my neighbor I will hop, borrow from the left, carry to the right. 11 minus 9 is 2, and 1 minus nothing is 1. So 12 students must have a color, an eye color, that is not brown. How many more, this is always a key phrase for finding a difference, which is subtraction. How many more children have brown eyes than have green eyes? So we're going to find the difference between the 9 children that have brown eyes and the 4 that have green, and we get a difference of 5 children. On number 6, we have to find the missing addend or the missing factor that would make the equation true. This equal sign tells us both sides of this equation need to equal the same thing. They need to be balanced. If this side equals 100, I need to figure out what could I add to 32 to make this side also equal 100. Well, we always talk about whenever we have a missing piece, we can use the inverse operation with the numbers we have. So the opposite of addition is subtraction. So I can do 100 minus 32, and what's left over must belong to this value. So I'm going to do 100 minus the 32 I already know. I have to do some borrowing across here. So 32 plus 68 would give me 100. I'm going to look at the side where I know everything here, and I'm going to use that to help me with this side. 5 times 3 is 15. And this is showing us the commutative property of multiplication. If 5 times 3 is 15, then 3 times 5 is 15. Those numbers can commute to new spots, but they still have the same value. Now we're looking at the commutative property of addition. 23 plus 48 would equal the same as 48 plus 23. Those numbers can commute to new spots, but they still add up to the same value. On this side, I have a missing add-end. So I'm going to use the opposite operation with the two numbers I have. 100 minus 49. I'm going to have to borrow across. So I end up with a difference of 51. 51 plus 49 equals 100. Well, 7 times 3 equals 21. Let's apply the commutative property of multiplication. If 7 times 3 is 21, 3 times 7 is 21. They can commute to new spots, but still equal the same value. Commutative property of addition. 56 plus 17 would have the same value as 17 plus 56. On 105B, on number 1, Leanna bought 2 pencils. So I have 7 cents twice, and then 35 cents for the marker she bought. And real quickly, be sure that you write 7 cents with your $sign, decimal, 07. Because if I do a $sign, decimal, and I put my 7 right here, I'm saying that it's 70 cents. Do you see that? I would be saying it's 70 cents. 7 single cents would be decimal 07. So I did that addition right here, and I end up with 49 cents. She handed the clerk $1. So I have to find the difference between the $1 she paid with and the 49 cents she actually owed the store. And the difference is the amount of change that the store clerk should give her back. She paid 51 cents extra than she actually owed. On number 2, remember your place value house. We have the ones place, tens place, hundreds place, and the thousands place. So that value of the 3 is 1,000. So we would write it like this, plus 1 set of 100, plus 4 sets of 10, which means 40, plus 8 singles. Here we're going to write 61,000. I know that's my comma. 270. 2 sets of 100. 70 means 7 sets of 10 and no singles. So that reads 270. Circle the letters that have parallel lines. M has parallel lines. this one, and this one. And Z has a set of parallel lines, this one and this one. On this number 4, they've given it to us in digits, and we're going to write it in words. So this is 27, there's my thousands, comma, 186. A decimal says and 50 cents. So it would look like this. On number 5, I'm going to pre-label my bar graph. And again, it's skip counting by 2s. Brown is 8. Blonde, that would be a value of 3. Red, 2. And then black, so that would be 5. How many children have black hair? 5. How many children are in room 15? Let's add them all together. 8 and 3 is 11, plus 2 is 13, plus 5 is 18 students in room 15. How many children do not have blonde hair? So we take the 18 children in that class and take out the blondes, which was 3, and we have 15 children that do not have blonde hair. How many more children have brown hair than have blonde hair? So we take the 8 children with brown hair, take out the blondes, that's a difference of 5. On number 6, we're filling in the missing add-end here. And the difference, we're going to use the opposite operation. The difference between 100 and 28 would work out to be 72. Commutative property of multiplication. If 2 times 3 is 6, we can swap those numbers, and 3 times 2 is 6. Commutative property of addition. If 47 plus 38, then 38 plus 47, they would equal the same amount. We have a missing add-end, so I can use the opposite of addition. So that would be 26. 7 times 5 is 35, so we can swap those. Commutative property, 5 times 7 is 35. 56 plus 19 would equal the same as 19 plus 56.